Hello, dear students. Welcome to the channel and welcome to this playlist in which we are going to discuss about the instrumentation and the sensors. And up until now, we have discussed in detail about different type of instrumentation. We have discussed about sensors. We have discussed about selection of the sensors. But today, I have decided to cover up the whole sensor portion in one video only. So we are going to discuss about the sensors, the definition point of view and their application perspective. We are going to discuss about the classification of different sensors with different applications and their ranges and how we can use them. We are going to see the working and classification of some particular selective sensors, and we are also going to discuss about different pros and cons of different sensors or in sensors in general. So if you haven't checked out previous videos, the link will be flashing on the top right hand side corner of your screen in the I button, so you can click on it and you can check that video out. And if you've already checked that video, so we shall continue to today's topic, right? So firstly, what is sensor to you? What will you call a sensor? Sensor is something that senses the information or the data, right? And if you want to define it in the technical terms, so you can call sensor, you can see it as a machine or module or subsystem or a device who serves the purpose of detection of change in any event or in any environment, and this information regarding these changes is further sent to the various other electronics, mostly comprising of a computer processors, right? So if you pick any sensor, it would most probably have some computer sensors, or it would send the information to particular computer sensors. Pick any sensor if you want to, it would do that, do that thing, right? Pick ultrasonic sensor, pick sonar, pick strain gauge, thermometers, anything. It will mostly comprise of a computer processor, right? And it's always used with different electronic devices or instruments, and about that we have discussed in the previous videos as well. And in today's lifestyle, if you would see, sensors would be very common thing, right? You will see different sensors being used in everyday life. Take it your table lamp, your television remote, your laptops, your mobile phones, your computers, even small simple devices in the kitchen comprises sensors these days. So for an example, let's take a lamp, right? That lamp that turns on by the touch sensation and dims and lights up by touching the base and touching the sensitive elevator buttons, right? So what is it? It is sensor. And with time we have seen advances and we will see more further advances in the sensory division in micro machinery and microcontroller platforms. We will see more advancements, and we are already have started to see some advancements in sensor domains in microcontroller and micro machineries, right? Because it's easy to use and they make our lifestyles easy. And with time, the application of sensors have increased beyond the pressure or flow measurement or traditional fields of temperature. We now use sensors for the parking as well, right? Your car will have ultrasonic sensors for the parking. We use sensors in mobile phones, optical sensors for camera measurements, uh, for face recognition, object recognition. We use proximity sensors in our phones. Accelerometers are more common these days as well. So the application of sensor has increased so drastically that It's everywhere, wherever you go, no matter in what part of the globe you are, right? And the applications are not only limited to the surface, but the airplanes, aerospace, medicines, manufacturing machineries, robotics, every single domain covers some aspects of sensories, right? And all of these divisions collectively are part of our daily lives. So sensors are available everywhere, and based on their application, we use the different sensors that we have seen in previous video as well, right? Now let's see the classification of sensors. So firstly, sensors are classified on the basis of the output signals, physical parameters measured by them, and different other points. And on the basis of the output signals, we classify our sensor to be required will be analog or digital, right? So sensors on the basis of the output signal are classified into the analog and digital output sensors as well. After that, the output given by the sensor in the case of analog output sensor is an analog voltage that can be measured and used to determine the required physical parameter. And how do we do it? So this is done by making use of sensors transfer function. It can be resistive, it can be capacitive, inductive, anything which is analog, but it requires to be analog. And about digital data, so the digital data which can be read via parallel or a serial communication buses in the output of a digital output sensors, the format for the data uh, would be available in the data sheet of that particular sensor. For an example, let's take an accelerometer, a digital sensor that is used for sending the output data by using I2C wire bus. And except for this analog and digital classification of sensors, we can also classify the different sensors on the basis of physical parameters as well, what something that we have already done, right? Like pressure sensors, cameras or optical sensors, magnetic sensors, color sensors, tilt sensors, light sensors, fingerprint sensors, proximity sensors. There are so many sensors available. So based on these applications, let's take bit glance of different type of sensors, right? So in our daily life, it has become our habit to implement different type of sensors frequently in the power system comprising of load control systems, electrical and electronic appliances, and industrial and home automations everywhere. And after that, we divide them in analog and digital sensors. However, there are few types of sensors that are used in electrical or electronic appliances, like pressure, touch, infrared, ultrasonic, temperature, proximity. So let's see these type of sensors one by one. And one type of sensor which I wanted to discuss, which we have not discussed previously, is the temperature sensor. So temperature is the commonly measured environmental quantity for so many reasons. And there are different types of temperature sensors that are used for temperature measurement. Like thermometer is something that you see very frequently for temperature measurement in living organisms like humans or any other living organism, right? In animals, in birds, insects, we use thermometers for us. But except that, we have thermistors, which is something that is used for the measurement of temperature. There are resistance temperature detectors, which are called RTDs. there are thermocouples, and there are semiconductor temperature sensors as well. And how would you select that I need this temperature sensor? Because the task they serve ultimately is measurement of temperature. Then how would you select if you would require RTD or a thermocouple, or you need thermistor or a thermometer? So on the basis of requirement, different type of sensors are used for the purpose of measuring temperature in different applications. And I'm putting more emphasis on the term different applications, because it is the most important part. Your application determines what type of sensors you require. So a simple temperature sensor with a circuit may be used for the switching the load on and off at specific temperature. And uh, the temperature normally is detected by temperature sensors, and in this particular case the thermistor is something that is more suitable. Then we have the temperature sensor circuit comprises a thermistor, transistor, relay, battery, everything. And temperature sensors activates a relay by detecting the required temperature. Okay, and what case I'm talking about? I'm talking about a case in which we use a circuit with a temperature sensor for switching the load on and off for a specific temperature. Okay, so you do not use the thermometer for that, right? Now this relay switch I just told you about, this relay switch on the load that is to it with uh, connected to it with uh, AC or DC supply, either of them. And this circuit may be further utilized by for the purpose of controlling the fan on the basis of the temperature. And primarily this type of sensors may be further classified into different type of sensors, like temperature sensors, and then you classify them in thermistors, thermocouples, thermometers, RTDs, semiconductor temperature sensors, and so on. After that, one more sensor which we have not discussed about would be the IR sensors, something that you see in your TV remote so frequently. So, in this, what do we see? The small photo chips comprising photo cells that are used for detecting and emitting the infrared light or IR light is termed as IR sensor. And these sensors are most commonly used for the purpose of designing the remote control technology in your television, in your AC remote, in your DVD or VCD remote, right? And all that remote technology, we used to use IR sensors. And these sensors may be used for detecting different obstacles of the robotic vehicles as well. And we can control the direction of it for the same as well. And there are different type of sensors that might be used for the detection of IR lights. And the basic and most simple example of IR sensor circuit that we use in day-to-day life is as I've said, television remote. So what does it have? It has a IR receiver circuit and IR emitter circuit, which is designed by the engineers. And then IR emitter circuit is used as a remote by the user for the purpose of the emitting infrared light. Now this infrared light that is emitted by the user is then transmitted or sent to the IR receiver circuit, which is interfaced to the device, like IR remote controller, remote controlled robot, or in this case the set-top box of your dish or a television itself. And then these sensors are further used for designing the TV remote controls. Now this TV remote is a prime example of simple IR sensor based electronic projects which are used for the purpose of controlling a robot vehicle in a remote area using IRs or TV remote. And except that it is also used in the satellite technologies as well, if you are aware of it. And this type of remotes which are being utilized for sending commands to the robotic vehicles as well. So if you have seen a robotic floor mopping device that that is being more that is becoming popular nowadays. So they use it as well. After that, we have the ultrasonic sensor. We have discussed about the ultrasonic sensors in detail, so I'm not discussing about ultrasonic sensors here because we have discussed in one of the previous classes. Now let's see the touch and the proximity sensors. So the switches that are activated by touch may be said to have touch sensors, and these sensors are classified in different type of bases of that touch types, like piezo touch switch, capacitance touch switch, or resistance touch switch. And for the purpose of controlling the load, touch sensitive load is designed, and the touch controlled load switch, which is which basically is a touch sensor, and its principle is based on various blocks such as touch sensor plate, load, relay, power supply block, everything. And you will find this touch sensor in laptops and mobile phones nowadays, except that you will find it in elevators somewhere, because there are some elevators and there are some refrigerators, even microwaves, who don't have buttons. They have just this touch sensors nowadays, so you can find it over there as well. Then we have the proximity sensor. It's basically an IoT sensor, which is in which the existence and non-existence of the surrounding objects is identified, but for very small range. Okay, so the detection signal is converted into the form that is that the user understands, and mainly these type of sensors are applied in the retail domain where the movement is found out, and association is present between the consumer and the product. For an example, think about your phone, your smartphone. So have you ever noticed whenever you are talking on your smartphone, and when your smartphone is close to your ear, the screen light goes off, and as soon as you remove the smartphone from your ear, when you see the distance between smartphone and the ear is very less, or very sorry, when you see the distance between smartphone and your ear is more, light will suddenly glow on. Now why does it happen? Because your proximity sensor is working, it is causing it. Your smartphone has a proximity sensor. So the users are provided with quick notifications related to the exclusive offers and discount updates of the products in which they are interested. This is not about smartphone. This was about the retail domain where it is used, right? When any movement is found out and association is present between the consumer and product. Then we have the chemical sensor and gas sensor. Chemical sensor helps in determining different kind of changes in liquid and for detecting air chemical variation, and these are mainly put to use in bigger cities like towers as an important to look after the change for providing safety to the people. And this type of sensor is essentially implemented in commercial atmospheric observations and used for processing management, which may comprises of uh, intentionally evolved chemicals, or even radioactive exposures, pharmaceutical industries, all they use, even the reusable operations in space stations use these sensors, the chemical sensors. But there are so many different types of these common these chemical sensors. So which are most frequently used chemical sensors? They are chemical FET, chemical field effect transistors, the electromagnetic gas type, the chemical resistors, non disparative infrared, we have the zinc oxide nanorod, you have fluorescent chloride types. All these chemical sensors are used very commonly. After that, we have the gas sensors, which are similar to chemical sensors but are specifically used for observing modification in the quality of air. And how do we do it? So we do it to find out which type of gases are present in air, and we use this sensor in multiple domains. We use it in health domain, manufacturing domain, agricultural domain, right? And all these domain have different applications of these sensors. uh, Coal industries use it for the supervision of gas, chemical laboratory use for supervision of chemicals, like gases in the form of chemicals. The health domain uh, uses for measurement of gas. Agricultural we used for the detection of certain gases in weather. So in different sectors we have different applications of gas sensors, and some of the gas sensors that has been put to use in these sectors includes hydrogen type, uh, hygrometer, carbon dioxide sensors, ozone monitoring, air pollution type sensors, gas detection type sensors, all such sensors. After that we have humidity sensor and acceleration sensor. This humidity sensor is used for defining the vapor present in the atmosphere or in the gaseous substances. And humidity sensors are used as temperature sensors, as the manufacturing operations required similar operating conditions. And by measuring humidity, it can be ensured that the complete procedure will pass away easily, right? So not only in the manufacturing department, except that there are so many other sectors where we use the humidity sensor, specifically when you have to arrange an event and you have to make sure that it does not rain during this event. And even in some particular sports like cricket, where we often use the humidity sensors to identify how humid is it, if there are any chances for rain or not. So there are so many sectors in which humidity sensors are used. And in case of modification, immediate action can be taken, as these sensors are known for the quickly identification of the differences or variations. And there are so many other domains in which these are used, like ventilation, residential, commercial use of heating purposes, etc. And other domains includes greenhouse, meteorology, automobile, painting, coaling industries, hospitals. So there are so many sectors in which humidity sensor is used as well. Then we have the acceleration sensor, which is used for calculation of acceleration and angular values, pretty much self-explanatory. And the accelerometer is primarily used for calculation of acceleration. And we all know that there are two type of forces that create impact on the accelerometer, right? Static and dynamic force. So these sensors are present in numerous configurations, and the types of selection is dependent on the industry's requirement, right? And not only accelerometer, most of the sensors type of selection is dependent on the requirement of the industry, because it is heavily dependent on what application does that sensor particularly serves. So because of that, it's dependent on industry's requirement. Now there are few parameters in that are required to be checked before selecting sensor, like total number of axes, bandwidth, sensitivity, type of outputs, etc. Then you have the sound sensor, which can generally be identified as a microphone devices or mics, and we use it to deliver the corresponding level of voltage and sound on the basis of the sound level detection. And by implementing this sound sensor, a small robot may be manufactured for navigation on the basis of sound receivers. Now, in comparison to light sensors, the design process of sound sensor is more complicated, because the delivery of minimum voltage will be different, right? So, uh, this can be further be amplified for providing voltage variation that are measurable. Except these sensor, there are so many different sensors like light sensor, tactile sensor, force sensor. And if you want to learn about different sensors, we already have a video on different type of sensors. I will give the link of that video as well in the I button on top right hand side corner of your screen, so you can click on it and check it out as well. Now moving forward, what are the uses of these sensors? Right, we saw it, it serves different purposes and used in so many different conditions. Now let's talk about them individually. Like starting from position sensor, which are used for the purpose of measurement movement, displacement, position, and maybe rotary and linear as well. So these are used for controlling the throttle, measuring the wind direction, positioning the ramp and bridge, simulating flights, and steering angle measurement. So see, it has the application not only on ground, it has the application in the sea, and it has the application in the wind as well. Right. Then we have the pressure sensor, which are being used for measuring the pressure and can be a differential gauge or an absolute gauge. The most common type of pressure sensor that are used comprises transducer, which are also known as the pressure switches or pressure transmitters. And where do we use these pressure sensors? We use it in the measurement of oil pressure, tire pressure. Whenever you go to the petrol pump, you will see the uh, the air compressor over there, which allows you to fill the air in the tire of your vehicle and measure the pressure of it. So it comprises of pressure sensor, vehicle braking system, oil pressure, fans, filters, diesel and engine applications. Now this the force sensors are known as the load cells or weight sensors, which are used for weighting applications in different scales. And what do? So they provide us the exact weight measurement by measuring amount of force that is being applied on it. And the load sensors are used in counting scales, hopper scales, platform scales, tank weighting, onboarding weighting. So all these applications we use the weight sensors. Then about the temperature sensors, what we have already discussed. We use it for the monitoring and measuring temperature of liquid, gas, and solids as well. We use it in our homes as well, and it is used in various shapes and sizes for serving different purposes. Right, so it serves so many different purposes. It's used in the motors, surface plates, computers, industrial equipments, electrical radiators, exhaust gas monitoring, home appliances. Everywhere you will see a temperature sensor. Right, even in microwaves. Now about digital sensors and their applications. So digital sensors are the electrochemical sensors or electronic sensors in which the transmission and the conversional of data takes place. And digital sensors are known to have overcome the drawbacks present in the analog sensors and have slowly begun to replace them as well these days. So we have different digital sensors as well, like digital accelerometer, digital temperature sensor, uh, digital pressure gauges, digital speedometers, tachometers, everything. So digital accelerometer is known for generating variable frequency square wave output, term term pulse width modulation or PWM, and in this the readings are taken at fixed rate by the pulse width modulation accelerometer. Then the digital temperature sensor is known for providing device temperature with 9 bits temperature readings and known for acting as a thermostat with the presence of three thermal alarm outputs. and it is being considered as a digital temperature control system that uses the digital temperature sensors, right? Now these control systems collectively have different advantages and provides accurate results in the comparison to analog temperature control system, and that is why we use them, right? It is capable for providing temperature display and switches off when the temperature exceeds the set point, and that is why we use digital sensors more compared to analog sensors these days. Now how do these sensors work, right? We know sensors act as per the changing physical conditions by bringing a change in their electrical properties, but how? Because they rely on electronic systems a lot for so many applications, information capture, analysis. So in all these applications, sensors uh, rely on electronic systems a lot. Or in other words, we can also say that sensor is something that converts the stimuli such as sound or motion or heat and even the light into different electrical signals, and then these signals are passed through an interference that further converts these into binary code, passing them onto a computer to get processed. Most of the times these sensors act as switch and are used for controlling the flow of electrical changes passing via circuits. Switches form an important part of electronics as they are known as changing the state, known for the change of state of the circuit. And these components present in the sensors like transistors, diode, ICs that consist of semiconducting materials, and these materials are included in the sensor circuit so that they can be used as a switches. Now most sensors are used radiations like laser or light, right? IR radio waves or other waves like ultrasonic for the detection in the change and object present in the environment as well. And that is possible if they have energy sources that assist them in emitting radiation in the direction of that target object. So this radiation is reflected back by the object and then gets detected by the sensor, and it is termed as an active sensor. And what is the passive sensor? Passive sensor is something that is opposite of it. Passive sensor something is something that doesn't send radiation or waves that are in their own, right, and detect what is being emitted by the target object, like thermal infrared radiation or heat or the radiation from some external source, right, like sun reflected off that object. Now let's see different applications or different advantages and disadvantages of different sensors. So uh, when it comes to touch sensor, the axle hole present in the sensor area may be used for creating its own bumper, and the color sensor is known for detecting color but avoiding ambient light and following lines. Then there is a gyro sensor that can be used for accurately turning and measurement of robot turning, and infrared sensor helps in finding beacon and remote receiver. So it's known for working and helping in measuring the proximity accurately, and an ultrasonic sensor measures in inches and centimeters, and it provides accurate distance measurement and wall following, but it cannot measure long distance, right? Its range it the range of the ultrasonic sensor is very small. So these were the pros and cons of different sensors. these were the pros of different sensors. Now let's see the cons. So about touch sensor. So touch sensor is the object that touch sensor is that the con in the touch sensor is that the object must touch the sensor's red part, and its sensor area is very small. Now color sensor, that is known to be reliable only when it is at close range and the light color that it detects is white. Now gyro sensor, the robot is required to be still when it is plugged, and it can be unreliable and touch many times. And for sound or ultrasonic is it may interface with the sensor. The infrared sensor is not allowed in FLL, and is not measured in centimeter, does not measure in centimeter or inches. So these were the pros and cons of different sensors. Now in next class we are going to discuss the sensors and application modes of different sensors. So if you have any doubts or queries related to this lecture, please mention them in the comment section below. If you have any suggestions or feedback related to the classes, mention that in the comment section below as well. I will be seeing you next time. Thank you very much for listening right now. Goodbye for now.